Okay, so our consulting firm called Neopotentia is undertaking a project to implement renewable energy sources in the United States of Africa, considering their future energy needs until 2050. So we're considering the most reliable and feasible pure natural energy sources. So we suggest that solar and wind energy be primarily implemented according to the geography and climate of the African continent. Alternative energy sources will be required to achieve the replacement of 50% of fossil fuel consumption with renewable energy sources.
For the solar energy, we'll consider two different sources to actually produce this energy. One is the CSP and the other one is the CB. In the CSP, we are actually planning to use that as a farm compared to the CP. Reasons for this is because there are case studies that have been done that shows that the CSP produces more energy on the same land compared to the CB. In the consideration for the wind turbines, for the wind energy, we'll be using wind turbines. These could be built on both land and water, but in our proposal, we're only considering it to be built on land at the moment, considering it's more costly to actually create them in the sea. These could be built pretty much in any mountainous regions, as long as it's a certain distance away from the populace, so that they're not disturbed by the noises.
Okay, so the plan for 2050 is that the United States of Africa currently uses 8 petawatts hour of electricity and is roughly estimated to be using 10 petawatts by 2050. The aim is to produce 50% of its electricity in 2050 from renewable sources, such as concentrated solar power and also wind energy. Realistically, the aim is to produce 1 petawatt hour per decade through new construction of renewable energy plants and through other sources such as photovoltaic cells. So the first step is to, the primary move is to achieve 50% is to install PV photovoltaic panels on major buildings in the cities, like Egypt, Lagos, Ghana, South Africa, Nigeria. For example, Lagos, a city in Nigeria, is the second fastest growing in Africa and the 7th in the world with 4.44% annual growth. We would change building standards to require them to install PV panels on new constructions, each generating 235 watts, which would result in about 12,000 kilowatts a year per major city. The second step would be more major, to significantly increase the power output using the vast deserts of Africa. For example, the Namib Desert next to South Africa is an ideal area to construct concentrated solar power plants. The objective is to install a 500 terawatts CSP plant in the Namib Desert, which would approximately take only 120,000 acres, while only using a fraction of one-third of the possible uses. And in addition to CSPs, wind farms would be installed in the mountainous regions of Africa, of USA, such as in Ethiopia, Swaziland, Tanzania. Wind farms similar to that of SFWF located in Arlington, Oregon. Such wind farms produce roughly about 2,000 gigawatts hour. And step 3, to connect it to the grid, we would use ESCOM, which is the largest distributor to connect US's power grid. They distribute all over Africa roughly 60% of USA's power needs to many customers, mining, industrial, and commercial, as well as residential.
In the aspect for maintenance on the solar side, the main problem would be is that it uses a large amount of water to clean both the mirrors, as well as to sometimes to reduce the heat generated from the turbines. But this is still much less compared to the fossil fuels used. On the side for wind turbines, you'll have them pretty much not dependent on water. The main thing for them is their maintenance and lubrication. These are the parts that you'll have to look into to make sure that the wind turbine is kept proper.
Okay, so in terms of future implementation, possible ones are to replace existing fossil fuel plants with renewable sources, and also including other sources like geothermal, tidal, and algae.